Hello, one and all. This is going to be a quick video for my Programming 2 class. Well, maybe not super quick, but a video. We're going to review over the entirety of Programming 1. Basically just a real quick rundown of everything we did, all the different code, what it does. Just really quickly go down my whole list here and we'll do a little bit of everything. Outside of this review video, if you're in my class, I also have all my previous videos posted, so you can check those. You want to go through each one individually at a little more length instead of just a quick brief overview. So, first things first, I have idle running currently until I find a better IDE. I'm just going to make a new file and start. So first and foremost is usually just basic printing things. So print hello there, like so. And if I were to run this, it should run over here and print whatever I want. Well, after I save it, of course. Review. Let's go with that. So there we go. Hello. So just a simple print. I can put whatever I want in here, really. I could also put numbers and symbols and various other things, and it should work as well. There we go. Now, I can also deal with comments. I should probably add that as well. So comment, just a simple comment, like so. That's not going to print or display anything. It's just going to be there for your personal understanding of what the code is doing. You should honestly comment as much as you can, because when you go back and look at code, maybe a week, a month, a year later, you may not necessarily remember why you did what you did, and having comments there really does help. And if somebody else looks at your code, also helps. They may not understand what you did or why you did certain things. So the next step is variables, and I'll throw in some prints along with the variables and stuff as well, but basic print. Variables are just a way to store information. In Java, you would have to declare what type of variable it is. In Python, you just simply have to declare the variable, for example. And of course, I can say this. So in this case, x is going to be an integer, 5, and John is going to be, well, a string. Let me go ahead and get my magnifier out. Let me help a little bit. There we go. Now, of course, there is one other variable we could have, which is, in this case, 1.5 or 1.4. That would be a float. And, I could just x, y equals true. And that would be a Boolean, basically. So it's a couple of different things we could have here for variables. Actually, I'm sorry. X, y equals true is capitalized. Right. Those are our different kinds of variables. And of course, I can print each of these if I want to. Print, I could say just x, and it'll print x. Like so, 5. If I print y, for example, well then it should print John. There you go. If I say print x comma y comma z comma, in this case, xy, it'll print it just like this. So you can actually print multiple variables in a single go. Now I could also, instead of doing it this way, I could do my variables kind of like this. Let's see here. I've still got the x, y, z, but we'll just go with a, b, c here. In this case, a, b, c equals green, comma, blue, comma, red. And then I can just print, in this case x, print y, print Z. And I should, hopefully, be able to print each of those individual things. Let's see, where is my, oh, well, I didn't actually, because I did XYZ instead of ABC. And that gets us into errors, which that would have been a logic error. You have, of course, logic error, and then you have syntax error. Those would be your two major errors that we see. Here we go. There we are, green, red, blue. Now logic error means I put something in here that I didn't mean to. The code still runs. A syntax error would be essentially this. Oh no, you did something wrong and it didn't run right. Usually it won't run at all if there's a syntax error. There we go. And as long as I got it right, it should run without any issues. There we go. So logic and syntax. And a logic could be, I did some math and it didn't end up correctly, or something like that. I'll just say num equals 10, num2, 1, equals 2.5, or something like that, right? And total equals num1 times num2. Print. The total is, and I have to put some quotes here. If I don't put quotes here, it's going to be a syntax error. So if I run this, it's not going to know what that is. So I won't like this, comma, total. Run. The total is 25.0. Now notice this was an int, basically, and this is a float. And since I multiplied them together, it just made it the bigger of the two, which is a float. A float has decimal places, like 7, 15, I forget what Python's maximum number of decimals is off the top of my head, but an integer is a whole number, a float has decimal places. And of course, a string can be a text is, I think it's like millions, billions, or whatever characters long. And a Boolean is a true-false. There is also dictionaries and ranges and a couple of other things, lists, tuples. We'll worry about those later, not for the review here. So that would be essentially your variables. We talked about data types and stuff. Let's talk about forcing a data type to be something else, because that can be particularly useful. So if I wanted to print something, let's just say I have my number 2 up there, right? And I want it to not be a float. I want it to be something else, or I want it to be a string even. So if I run this, I'm going to get 2.5 pop up on my screen. And that's a number, technically. But maybe I want it to be a string for whatever reason. Then I can make it be a string just by simply forcing it to be. I can come over here and say, let's see, to force it to be a string should be str, like so. Let's see here. And if I run it, let's see if we, yeah, it's going to technically be a string. It's not going to look any different, but there are times where you don't want it to be a number. Or there are times where you want it to be a number, but it's a text. User input would be a good example of that. When I take user input, it's almost always going to be a string. And I have to convert it from one or the other. Now hold on one sec. Okay, we're back. So, I did just do a quick check here. Since we're on the topic of user input, had to make sure I'm doing what I'm supposed to be doing. All right, so here we go. So if I do have user input, in this case, I'm going to put in age equals, let's see here, input, type your age. All right, now if I run this, and get my stuff back up the way it was, there we go. All right, yeah, There we are. All right, so it's going to go run all the code, and then it's going to sit here. The program is actually still sitting here waiting for me to do something. If I type in a number, whatever I type in is going to get plugged into here. So if I were to say print your age is, comma age, then that's fine. Whatever I typed in will be whatever I typed in. So number there. Now the problem is this is going to be a text. So if I try to do some math age equals age plus 5, and then I try to print math age, actually that probably won't do what I want it to do anyway, but I'll run it, I'll type in a number, and it's going to crash. You're going to get an error. This would be a logic error. Now that's because this is a text and I'm adding 5 to it. It doesn't want to do that. So what I can do to fix that is, make it an int or make it a float even. I can cast it, force it to be another number. Type in my age. There. And now it's a number. And honestly speaking, you can do that ahead of time too. I could do that here if I want to. And then I don't have to have that line there. I can simply just say age. And we'll just say 9,000 even, 9,005. So you can force it to be whatever number you want it to be beforehand. And honestly, I think that's better. But if you want to take the second step and do it that way, that's perfectly fine too. So, move on down. We've talked about print, variables, user input a little bit here, changing user input, casting it, and that whatnot. So now we've got if statements. So if statements are just conditional statements that occur if something is true or false. So if I were to say, just make a couple of little variables, I'll just say var1 equals 0, var2 equals 10. If, in this case, var1 is less than var2. I put a little semicolon here, and it's going to tab me over, and I print var1 is less than var2. So if that is true, it will run that. And of course, I'll have to type in my stuff from previously. var1 is less than var2. Now, if I were to change this, and this is now 11, this would fail and it just wouldn't print anything at the current moment in time. Now, if I don't have this tabbed over, like that, it's going to have some issues because it's not indented. Anytime you have an if statement or some loop statement or something, you have to have 1 semicolon, and 2, it needs to be tabbed over so we can see it. So it knows that this is inside that statement. In Java, you'd have braces that would separate it so you can clearly see what's inside what. In Python, they don't require it. They want you to tab it over like this. So it does make it a little bit harder, but it's not too bad. Now, if I wanted it to do something else, I can put an else statement here. It's not. Like so. And I can run it. Well, let's just change this to 20. It should say it's not, because 20 is not less than 10. So I'll run it. I'll type in my age. It's not. Now, if I wanted multiple possible outcomes here, I can use what's called an elif, which is an else if. And I can say if var1 equals var2 in this case. So in this case, I'm saying if the first one is smaller, print that. If they're the same, print this. Print They are the same. So now I've got three options here. Option 1, if the first one's less than. Option 2, if they're the same. And else would be any other outcome, which there's only one other outcome, which is the first one's bigger. So I run, get past that after a minute. Oh, got to be on the right line. There we go. It's not. All right, so if I make this 10, it should say they're the same now. They're the same. So this is your if, else, basically. And I can have this whole setup, as many elifs as I want in here. But you can also nest them. I can actually put an if inside of an if I need to. Now if I come down here and have another if like this, these are separate. This right here is all considered kind of one statement. It's going to pick one and run it. And if this runs, it's not going to do any of these others. But if I put an if like this, it's a separate question altogether. If this is true, it'll run that. If this is true, it'll run one of these. This is one of the common errors people run into. They'll do if, and then it's possible that every if could run if you do it that way. If you just want one choice, then you're going to have to actually go down this whole list and make it like this. If, else. Only one of those will run. All right, nested ifs would be an if inside of an if. So I can say, I guess I'm going to need another variable here. So let's just A equals 1, capital B equals 2, capital C equals 3. So I can just say, if, in this case, and you can put parentheses here if you want. It's not necessary for Python, but if A equals 1, and I can say, let's just say this, if B equals 2. Print, huzzah. So in this case, I've got what's called a nested if. The first if will check, and if that's true, it'll go to the next one. If that's true, it'll go to the next one. So in this case, I should get a huzzah on my screen. Now, if the first if fails, if I make that a 2, then it will never run this one. It'll never even check it. Even if it's true, it's not going to run it. So now I can also do if, elif here, else. If I want to, I can put that inside that just like that. You can do this as much as you want. I can come in here, put an if inside this, and then a whole set of else if statements. Same for this. You can nest them as much as you want. I can even nest the third one in here if I want to, if C equals 3. Woot. And it'll check the first one, the second one, the third one, and if all of those are true, it'll run this here. Now this is nested ifs. You can also do compound ifs. And that would just be if A equals 1 and B equals 2 and C equals 3. Woot woot. Right. And we'll hit that thing there. Oh, I crashed because I typed in a plus. Whoops. Try it again. There we go. Woot woot. So which one is correct, a nested or a compound, depends on what you're coding, honestly. And actually I need to move this guy over there. There we go. Because this is a separate question compared to that. Although even if I had it spaced over, it's probably still going to treat it the same. Now I can have and, or I could have ors for this. So it can be this and this, or this or that. If I say and, both of these statements here have to be true. In this case, I have 3. All 3 have to be true at the same time. If I put an or, then that means only one of these two have to be true for this to work. So So for example, to open a door, I need a key, or I need a certain strength so I can knock it down. Those would be my two conditions I would check, this or that. If I needed 2 keys to open the door, I would need this key and this key to open the door. All right, compound ifs. We move on down a little bit further. And now we've got random numbers, just real quick. In order to use a random number, I have to import the random. And then I can just use it pretty much. Random equals random.randint. And if I were to say 50, 100, it would give me a range between 50 and 100. And random number generation is very useful in a lot of different places. What's that? 59. If I run it again, I'll get a different number. And it'll be within these 2 ranges that I put here. We'll use random number generation for a couple of places actually in our programs coming up. So just a little reminder of how that works. All right, now loops. There's 2 kinds, a for loop and a while loop. A for loop is fairly straightforward. It goes a certain number of times. If I say for I in range 0, 5, for example, I say print hi, it's going to print that phrase this many times. Now if I were to run thing, you'll see 1, 2, 3, 4, 5. So this goes 5 times. It starts at 0, it prints, and every time it goes through, it adds 1 to this little letter that starts at 0. So it'll be 1, 2, 3, 4, 5. If I were to print the I as well, you'll see that it actually, over here, 0, 1, 2, 3, 4. So those are the numbers that it rolls through when it runs. And I can change this to do, 5,000 times if I want to. That's how you would end up doing that. Now, if I were to say end equals 5, I could come in here and just use that variable. Or if I use this as an input, I can run this loop that many times. So the numbers here don't have to be written in. You can use variables for those as well. And it would still work just the same. Now that's a basic for loop. A while loop works pretty similarly. All the parts and pieces are the same, but I would say count equals 0, while count is less than 3. And I'm so used to putting these parentheses that I just put them on everything, but you don't necessarily have to have them, but it doesn't hurt to have them. Print fuzzy pickles. Now, if I run this as it is here, what I'm going to get is what's called an infinite loop, because count is 0, 0 is less than 3, fuzzy pickles. Count is 0, it's less than 3, fuzzy pickles. What I need is the extra count equals count plus 1, which adds 1 to it, basically. This way, I can actually make it do what it needs to do. Now I can run this. Come over here and type in my things. Fuzzy pickles 3 times. I typed in 3, so it goes 0, 1, and 2. Now you can also have an else for that if you wanted to. I don't often use that, but print it has ended. Prints it 3 times, and once it finishes, it will go to the else and print whatever's there. Although, even if I didn't have that, and I did this, it would amount to the same thing. There's really no difference between those two unless you just like having that there. Now, nested ifs, I can put a loop inside of, or I'm sorry, nested loops, I can put a loop inside of a loop. So up here, I could come down here and put another while loop, or another for loop inside there if I want. There we go. So I'm going to forego that just for the sake of time, but you could do a for loop and then right here on this line do another for loop. And typically that would be I and the next for loop would be J. The reason we use I and J for these are just historical. It was the first letter that was relevant, that was not reserved, and all the books and teaching materials always use it, so more historical reasons. You can use whatever letter you want, honestly, now. But back in the day, that wasn't the case. And people still use it the same way. Last but not least is functions. In Java, they'd be called methods, but they amount to the same thing. So what a function is just a set of code somewhere else, separate from my main code, and I can run it, elsewhere. So usually the function would be like way up here at the top. That's usually where I'd put mine. And it starts off with def. Let's just go with that. Print, oh no's. It's a function. Now, if I run this code, that's not going to actually run. You'll see nowhere does it say, oh no, it's a function. But if I come up here and I go to my very bottom and I say my function. So if I spell that right, it'll run it. And I can run that, I can have literally thousands of lines of code right here. And with one word, I can run those thousands of lines of code. This is great for if I have a map or something I want to display or something along the lines of that. That's what this is for. So we scroll on down. That's a function. And I can have multiple functions if I need to. This function that I've made here just simply print something. But you can also give it something. Let's see, the value is x. So in this case, if I say my function, and I got a little extra thing there, and I get it up, there we go, and don't give it anything, it'll run this. If I use this one, it's gonna, and I give it something, it'll run this one. So if we go down a little bit, and I say my function, and I give it, I don't know, Bob or something, we'll see. Oh, okay. I am thinking back to my Java, I think. So let me fix that for you. Let's go up here. My function 1. That's the one problem with doing multiple languages at once. Oh, nope, still got a problem. Let's see. And this also shows you that no matter how good you are, how well you do, you're going to screw up on something some point in time. Wait, is it just because of this? My function 4? Surely not. Let me see. No, that's not the issue. What's my issue? My function takes positional arguments. Oh. No. Okay, I see now. My function 1 is what I changed the name to. Thinking Bob. Now let's try. There we go. It's complaining because I gave him the same name. In Java, you can do that, as long as it has a different value you're passing. Python apparently is more picky about it, so I have a different name for each one of these. And these won't run unless you tell them to run. But it's a very good way to kind of parse out your code. If there's a problem, if something crashes, I can find that it's definitely in this section. It narrows down, my ability to find where the problem's going to be. Makes it a lot, instead of looking at thousands of lines of code, I only have to look at hundreds to figure out what the issue is. So it kind of puts all related code together, makes it easier to call, makes it easier to find errors and all that there. And that is essentially puts us up to snuff right where Programming 1 kind of ended. So to continue onwards here, we'll basically continue onwards with functions, methods, and keep pushing along. So that is your review over the entirety of Programming 1. So hopefully you enjoyed that. Sorry if I bounced around a little bit, but that should give you kind of a rough review. If you want a little more thorough review, you can always check back at my other videos. I've got a whole bunch of them. And if you're in my programming class, they're all listed right there in the modules, all up and down. If you're just looking on YouTube, well, they're all listed there and sorted, I think, as far as I believe anyway. And you can just go through each one if you want to go over some particular topic or anything. That's it. Hope you enjoyed.